तो क्वेश्चन 6 से स्टार्ट करेंगे. द रेड लाइट produced by a laser is monochromatic. So what is the meaning of monochromatic? ये लास्ट टाइम भी हमारे पास वैसे किसी क्वेश्चन का पार्ट था, तो इसमें कोई प्रॉब्लम नहीं होगी.
Light of a single frequency.
यस. Red light from the laser hits the curved surface of a semicircular transparent plastic block at point B and passes into the plastic. ठीक है, मतलब वो रिफ्लेक्ट बैक हो गई प्लास्टिक में. द रेड लाइट ट्रेवल्स थ्रू द प्लास्टिक and hits the straight edge of the block at its midpoint M. तो यहाँ पर आप देखो दो वेव्स लाइंस हैं यहाँ पर लाइट की. फर्स्ट, सेकंड. And figure 6.1 shows that some of light is reflected and that some light travels in the air along the straight line edge of the plastic block. Speed of the light in air is 3 exponent 8 meter per second. Explain why red light does not change direction as it enters the plastic block. तो अब आपने बताना है द रेड लाइट एंटर्स फ्रॉम द लेजर हिट्स द कर्व्ड सरफेस, और laser is like moving from rare medium because this is rare, and plastic is a dense medium. So basically the question is why red light does not change direction as it enters the plastic block. तो जब वो यहाँ से प्लास्टिक ब्लॉक में एंटर कर रही थी तो उसकी डायरेक्शन चेंज नहीं हुई, क्योंकि रिफ्रैक्शन में तो हमने स्टडी किया है कि जब मीडियम चेंज होता है, so definitely direction of the light ray also changes. Either it will bend towards the normal or away from normal. So why this light is not changing its direction? Why it is not bending in any other way? So what is the reason? What is the logic of it? अच्छा, वैसे ये इजी पार्ट है, ये हम 23 के पेपर में भी देख चुके हैं. उसमें भी एक सेमी सर्कल इस तरह का कर्व था. ठीक है. और जब भी हम एंगल मेजर करते हैं, सो वी ऑलवेज यूज टू मेजर विद द नॉर्मल. और अगर आप यहाँ पे नॉर्मल ड्रॉ करते हो तो ये जो आपकी लाइट रे आ रही है रेड कलर की फ्रॉम द लेजर, सो दैट लाइट इज आल्सो ऑन द नॉर्मल. तो जब लाइट बिल्कुल नॉर्मल पे ही ट्रेवल कर रही हो तो आप यहाँ पे देखो कोई एंगल ऑफ इंसिडेंस ही नहीं होगा. सो दिस इज द रीजन दैट लाइट स्ट्रेट ट्रेवल करेगी विदाउट एनी चेंज इन डायरेक्शन. तो ये रीजन है आपके पास कि लाइट जो है वो बेंड नहीं करती. ट्रेवल्स इन द डायरेक्शन ऑफ नॉर्मल. तो एंगल ऑफ इंसिडेंस तो इस प्रॉब्लम की वजह से जो है वो लाइट डायरेक्शन चेंज नहीं करेगी, बिकॉज इट इज ऑलरेडी मूविंग इन द डायरेक्शन ऑफ नॉर्मल with angle of incidence 0. Part 2, at point M, the angle between the red light in the plastic and the normal is 37 degree. Calculate the speed of the red light in the plastic. Point M. This is point M. This is angle of incidence 37 degrees. Speed of light is given, and they are asking about the speed of red light in the plastic. So this is the speed of light in air, और आपने फाइंड आउट करनी है इन प्लास्टिक। तो किस फॉर्मूला से आप कैलकुलेट करोगे? क्योंकि यहाँ पर आपके पास और कोई हिंट भी नहीं है, स्पीड ऑफ लाइट इन एयर गिवन है और ओनली एंगल ऑफ इंसिडेंस इज गिवन विच इज 37 डिग्रीज। और अगर आप स्पीड ऑफ लाइट के फॉर्मूला की बात करो तो यहाँ पर एक फॉर्मूला जो है v इक्वल्स टू एफ लैम्डा हम यूज करते हैं वेव्स में। इस सिचुएशन में तो बिल्कुल नहीं यूज हो सकता, क्योंकि इससे रिलेटेड कुछ भी हिंट गिवन नहीं है क्वेश्चन में। तो ये तो हम यूज नहीं कर सकते, ना फ्रीक्वेंसी है ना वेवलेंथ है, सिर्फ एंगल का रेफरेंस गिवन है। तो यहाँ पर हम एक कॉन्सेप्ट यूज कर सकते हैं। आपके पास एक फॉर्मूला था रिफ्रैक्टिव इंडेक्स की फॉर्म में। रिफ्रैक्टिव इंडेक्स इज इक्वल्स टू स्पीड ऑफ लाइट इन एयर डिवाइडेड बाय स्पीड ऑफ लाइट इन मीडियम। एक तो आपके पास वो रेफरेंस है, आप उससे कैलकुलेट कर सकते हो, ठीक है। और उसके अलावा और कोई फॉर्मूला आपके पास ऐसा नहीं है जो स्पीड के लिए आप यूज कर सको, ठीक है। सो द ओनली फॉर्मूला दैट वी कैन यूज, n is equals to speed of light in air divided by speed of light in medium। speed of light in air, speed of light in medium। Okay, now in the diagram you can see light ray is completely reflecting back, some part is reflecting back, some part is refracting. So basically this angle of incidence is the critical angle, because at critical angle light refracts at 90 degree and some part also reflects. So we use the idea that angle of incidence is equals to critical angle. So first of all, we have to find out this refractive index. N is equals to 1 over sine C. So N is equals to 1 over sine 37, because in this formula, value of N is also not given. So first of all, we have to find out this value of N by using the concept that angle of incidence is equals to critical angle, because light is partially reflecting and partially refracting. So you will get answer 1.7 for the refractive index of this plastic. Now again we use this formula. Again we use this value in the new formula, that is N is equals to C over V, speed of light in air divided by speed of light in medium. And we have to find out the speed of light in medium, plastic medium. So this will be equals to C over N. Speed of light is given divided by refractive index. So 3 exponent 8 divided by 1.7. And you can see that's why you are getting 4 marks for this part, because this part is detailed one. It is not very simple that we use one formula and we will get the answer. So that's why we have to solve this part like this. And in third part, in the plastic, blue light travels slightly slower than the red light. And so the critical angle for the blue light is smaller than the critical angle for red light. The laser that emits red light is replaced by one that emits blue light. Now blue light enters the block at P and hits the straight edge at M. So actually what is happening? First they mention blue light travels slightly slower than red light. This is the point. And then they mention critical angle for blue light is also smaller. So critical angle of B is less than critical angle of red color. Now we replace red color laser light with the blue color laser light. And now blue enters the block and hits the straight edge at point M. So now explain what happens to the blue light after it hits the straight edge at point M. Okay. Okay. In this question, we got the hint that the critical angle of critical angle of blue light is less than the red light. And we know one thing, that the wavelength of red light is greater than the blue and red light refracts less than the blue. Okay. So it is also a fact we know from the wavelength and the frequency. So if we talk about red light, so red light refracts less than blue color. So it means the angle of this incidence will be greater than uh, of blue light will be greater than the angle of incidence for the red color. So angle of incidence for blue will be greater than angle of incidence in red color, because red color refracts less. So it has short angle, but blue color refracts with greater angle because it refracts more than red color. So this is another idea. So angle of incidence for blue color is greater than red color. So basically red color lights refracts and reflect partially, but blue light will completely reflect back, right? Because its angle is greater, angle of incidence, and its critical angle is short. So definitely we exceed the critical angle value. So blue light completely reflect back into the plastic medium. So total internal reflection occurs for blue light, क्योंकि इसका एंगल ऑफ इंसिडेंस ग्रेटर है और क्रिटिकल एंगल शॉर्ट. सो डेफिनेटली जब एंगल ऑफ इंसिडेंस ग्रेटर होगा, इट मींस क्रिटिकल एंगल को हम क्रॉस कर चुके होंगे. तो ब्लू लाइट कंप्लीटली रिफ्लेक्ट बैक हो जाएगी सेम मीडियम में, एज कंपेयर टू रेड लाइट विच इज partially reflecting, partially refracting. So this is question number 6. Okay, question number 7 of plane mirror. It is a plane view. It shows a plane view of a room. There is a plane mirror also on the wall with a picture across the wall, whole of wall AB. Okay, so there is a picture on a complete wall of AB from left hand side. A person is standing at point X, okay, and is looking at the mirror. The person cannot see all of the picture on the wall AB reflected in the mirror, but there is a point P on wall AB, which is the closest point to A. So basically, जो X पर ऑब्जर्वर खड़ा है उसे कंप्लीट पिक्चर ए बी की तो नजर नहीं आ रही, बट देयर इज अ पॉइंट पी. एक पॉइंट पी है जो से विच इज क्लोजेस्ट पॉइंट टू ए. वो पॉइंट ए जो ए के क्लोज है, यानी वो कहीं यहाँ पर होगा. The person can see reflected in the mirror. Draw a reflected ray and an incident ray to show the position of the point P. तो ये जो पॉइंट पी होगा आपके पास, जो ए के क्लोजेस्ट की आपने रिफ्लेक्शन शो करनी है. और एक चीज और, इसका मैं आपको एक और क्वेश्चन का स्क्रीनशॉट सेंड करूंगा. ये क्वेश्चन जो है वो रिपीटेड है. Basically repeated in the sense this question is already asked in 5054 O levels. So ये सेम क्वेश्चन उसी तरह से. तो बेसिकली
Wait, sir, the exact question?
एग्जैक्ट सेम. बेसिकली उसमें बट डिफरेंस ये था, उसमें एक
Oh,
पर्सन की पिक्चर गिवन थी यहाँ पर, और उसमें पॉइंट यहाँ पर था.
X.
तो बट ये डिफरेंस था. ठीक है, वो मैं आपको सेंड करूंगा. 5054 का है, आपके सिलेबस का नहीं है, तो इसलिए वो दोनों वर्कशीट्स आपको करवाएंगे क्योंकि उसमें क्वेश्चंस इंटरचेंज होते हैं कभी कभार. सो बेसिकली एक पॉइंट पी है दैट इज क्लोज टू पॉइंट ए. तो आप मिड वे से उसे थोड़ा सा ऊपर अपनी मर्जी से कहीं भी बना सकते हो. इट्स योर चॉइस. इट इज नॉट कंपल्सरी दैट देयर मस्ट बी अ फिक्स इक्वल लेंथ फ्रॉम ए, क्योंकि सब अपनी अकॉर्डिंगली जो है वो ड्रॉ करेंगे, क्योंकि कोई पोजीशन मार्किंग नहीं है. सो फ्रॉम दिस पॉइंट नाउ यू नो angle of incidence must be great equal to angle of reflection. So angle of incidence will be equals to angle of reflection, and this is the point P which is observed by the observer standing at point X. So this is the concept. And then state two properties of the image formed by the mirror. So we know about the properties virtual image, same size, or you can mention laterally inverted, upright. So these are some properties of image formed by the plane mirror. Part C, visible light is an electromagnetic wave. State the name of one region of the electromagnetic spectrum in which the waves have shorter wavelength than visible light. So you have to mention the name of one region of the electromagnetic spectrum in which the waves have shorter wavelength than visible light. So in which region you will find shorter wavelength than visible light?
You mean like gamma and X-ray?
Yes. So basically, when we are moving towards greater frequency, it means we are moving towards shorter wavelength. So on the other side of the visible light, we have gamma rays, X rays, ultraviolet. Okay. So it's up to you. You may mention ultraviolet, X ray, gamma. So they all have shorter wavelength than the visible light. And in part two, you have to mention longer. So definitely the rest of the
Yes, yes,
three.
you're right.
Yes. We have infrared, microwaves, radio waves. So these are the waves with longer wavelength. Okay, question number 6. It shows crest of a plain water wave approaching a barrier with a gap, and there is also a direction of travel of water wave. So draw three crusts of the water wave to the right of the barrier. So you also find this question that this type of question is also repeated in new airs mostly. So waves will be semicircular or like a curved one. Because first of all, if you
Semi,
compare the gap, so this is the gap, this is the wavelength, and this is the gap. So basically, when your gap is shorter than the wavelength, so we have to draw semicircular. And basically, why you are getting 2 marks for this? First of all, you have to identify the correct shape. So 1 mark for that. And the second thing is you have to uh, draw the same wavelength on the right hand side. It is not like that you have different wavelengths of the waves, like when you draw one semicircle, then the other, then the third one. So it will not like completely different from each other. So you have to follow the same wavelength on the other side. Okay. So these two wavelengths are, because a medium is not changing, we are in same medium. So when we are traveling in same medium, so there will be no change in speed, no change in wavelength. So that's why you have to follow the same wavelength on the other side also. On paper, you know that you can measure this distance easily by the ruler. So you mark one point over here and measure that distance, point another mark, and from that point another mark. So it will also help you to draw the points from one side to another side of almost equal wavelengths. Basically, it is not compulsory that it will be accurate, but it will not like, let's suppose if I draw semicircles like this, right? So some students draw like this very small. So it is clearly not equal to the wavelength of the incident, right? So try to make as much as visible, just like the wavelength of the incident, because 1 mark is for that concept. Okay. Because markings are not given, so it is not compulsory to show exact wavelength, but this concept is important. You have to keep that point in your mind while marking the semicircles. Then in part 2, we have a crust of plain water wave in a deep water approaching a region of shallow water. So this is direction of water waves, and it is traveling towards shallow water. And again, they ask you to draw the three crust and the direction of the travel of the wave in the shallow water. So what happens that the wavelength, this is the length of the waves before moving into the shallow water, and when they enters into the shallow water, so their wavelength decreases. So you have to show refraction also, and also compare their wavelengths. Because their wavelength decreases, so wavelength will be decreasing in the shallow water as compared to the deep water. So this is also important to show, because in shallow water, speed and wavelength both decreases. And definitely the direction of the wave is still perpendicular to it. Waves are still traveling in the forward direction. So that is the direction of travel. And the other parts are theoretical, that are simple. State two ways in which transverse waves differs from longitudinal wave. So that is very simple. In transverse, particles vibrate perpendicular to the propagation. And secondly, transverse waves have crust and trough. In longitudinal wave, we know that there is compression and rarefaction, but in transverse, we have crust and trough. And state a typical value of the sound, speed of sound in water. So if you remember that value, not exact value, just typical approximate value. The speed of light in air is around 340 meter per second average, and for liquid we use 1500, 1600. So it will be like 1000, between 1000 and 2000. So that is the speed of sound in water. And if we talk about in solids, so that will be 5000 to 6000. And explain why sound travels faster in water than in air. So that is also simple, because molecules are close to each other. So that's why they transfer energy more quickly as compared to the air. Okay, now again we got question from the lenses. Figure 6.1 is a full-size ray diagram showing the formation of an image by a thin glass lens. Determine the focal length of the lens. So basically, for that you have to measure with the help of the ruler. And first of all, you have also need to know that where is the point focal length. So this is the point of focal length, because parallel line always passes from this point, which is the principal focus. And to measure the focal length, we have to use ruler to measure this distance. This is focal length. So on paper, you have to use ruler to measure this length. So basically, you will get answer around 2 centimeter, because for that you need a paper. So on paper, exact length you can measure with the help of the ruler. On screen, we can zoom in, zoom out, so that will change the length of the lens. So I just write down the average value from the marking scheme, because in marking scheme it is mentioned minimum 1.9, maximum 2.1. Okay, now circle three items in the list which describes the nature of the image form. So according to the ray diagram, you can see that the height of object is less than the height of image. Height of image is greater than the height of object. So it means image is enlarged. And what do you think? Is it real or virtual? It is also real.
Really?
Yes. And inverted, upside down. So this is also a very simple question. And state one feature of virtual image. So we know that we can define virtual image with two different points. Either we can define it cannot be obtained on the screen, or the second point is light rays will not merge at a single point. So that's how we will not get a real image. So not an intersection of rays, or we can mention image cannot be formed on a screen. Okay, question 5 is also short. Okay, let's try this one first. Question 5 is also very basic, related to just same V equals to F lambda formula and the name of electromagnetic spectrum. So this is again a full scale diagram of a small nail n in front of a thin converging lens. The line capital L represents the lens. The focal length of the lens is 3 centimeter. So the rays of light parallel to XY are traveling towards the lens. Parallel to XY. Okay. So describe what happens to the light after it passes through the lens. So they are asking in theoretical form, light ray which is parallel to XY. You can see this is point X, this is Y. So basically they are talking about principal axis indirectly. So when light ray travels parallel to the principal axis, so what happens? We know that it passes from the principal focus. So all light rays meet at a point after passing through principal focus. And we know that after they focused on a one point, they starts to move away from each other. Then all the light rays spread out from this point. And you can also mention all parallel light rays will pass from this point, which is at 3 centimeter, because focal length is at 3 centimeter. On figure 7.1, mark and label with an F each of the two principal focuses of the lens. The small nail n, height of 1.2 centimeter, is positioned at 2 centimeter to the left of the lens. By drawing on figure 7.1, find the position of image I of n and add image I to the diagram. Okay, and then we have to explain either it is real or virtual. So basically, we know that focal length is equals to 3 centimeter and all the markings are given. Again, 5 boxes is equals to 1. So 5, 10, 15. This is principal focus on right. And then 5, 10, 15. This is the other focus on the left. And the light rays will pass. First light ray will pass parallel from the focus. Sorry, parallel to the principal axis. Passes from the focus. And the second one will pass from the optical center. So now they are moving away from each other. So when they are moving away from each other, so definitely they will not intersect at a point. So when they are not intersecting at a point, so what happens? We have to extend them back in backward direction to get image of the object. So if we extend them, so definitely at some point we got the image. So this is the image. And this image is virtual because it is not obtained on the screen. Because not obtained on the screen. And state the name given to a lens when it is used in this way. So we also need to mention the name that in which application we use the lens in this way. So that is a magnifying glass, because in magnifying glass, we use the concept like this. That object is highly magnified and image is on the same side of the lens. Okay, this is also easy one. And okay, prism. Prism is also not difficult, but let's do just prism part of this question. It shows a ray of green light, okay, emerging from one face of a glass prism. On figure 7.1, draw the path of the green light entering and passing through the prism. Okay, so basically what happens with the green light, let's suppose green light is entering. So definitely it will bends into the glass medium. Okay, sorry, it is emerging. Uh, this light ray is emerging on from the left hand side. So it means it is entering from the right hand side. So we have to draw from the right hand side. So when it enters, we have to draw. Then it bends and it starts to travel in this direction. Because green, yellow, orange, red. So green is like away from the red. So red color refracts the less. So green color refracts more than the red. So in this way, you can draw the ray diagram. Again, they are asking the same monochromatic speed of light in air. So these parts are the same repeated from the previous questions. Okay, this is also easy question. Describe an experiment to determine the speed of sound in air. If you remember, we discussed this topic in our class that two peoples are standing at 100 meter away from each other. One people have a wooden blocks, two wooden blocks in his hand, and the second person having a stopwatch. And when the first person just claps those blocks, and the second observer just observed that it started the stopwatch, and when he hears the sound from the clap of that block, so it stops the stopwatch. So it will give the time, and distance is already given. So in this way, we can calculate the speed of sound. So this is a complete process that is already given. I will show you that we discussed in the wave section. So this is a complete copy paste question. You don't need to worry about it. Light, electromagnetic spectrum, sound. Yes, this is determine the speed of sound. So these are all the steps that we discuss. And two people stand at a distance of around 100 meters apart. So this is the same part you have to mention over here. And you may draw a label diagram according to that. Just mark 100 meters and show two persons, one having a stopwatch, second having a block. So that is the answer of this sixth question. Okay. So this is also easy. Okay, question number 7. It shows a ray of light approaching face AB of a glass prism of refractive index 1.5. On figure 7.1, accurately draw the path of the ray within the prism from face AB to AC. You will need to make a measurement from figure 7.1 and carry out a calculation. Okay, so we have to take measurements from the diagram to calculate the rest of the quantities in this question. So basically, when light enters into it, so let's suppose if this is normal line. Okay, so basically we know that we have to measure angle with the normal. So if you got confused how to draw the ray diagram, so it is very simple. Just draw a normal line for your reference, and it will help you when light enters from a rare medium to dense medium. So it bends towards the normal. So it means you also need to make a line which is bending towards the normal like this. So you can see this is the original direction of the light ray, but light is bending towards the normal. So this is the refracted ray, and this is the part of the question from AB to AC. So we make the refracted ray from AB to AC uh, and carry out calculation. Okay, 4 marks. Refractive index is given and it shows a ray of light. Okay, and on figure 7.1, accurately draw the path of ray within the prism from face AB to AC. You will need to make a measurement from 7.1 and carry out calculation. But calculation for, okay, so you have to determine the angle of incidence. Okay. So for angle of incidence, what you have to do, you have to uh, make the calculation from it, because this is angle of incidence. Only refractive index is given, right? So that's why they ask you, you may carry out calculation from this. So you have to measure the angle of incidence from this diagram and angle of refraction also. So for that, you need a protector to measure this angle. angle of incidence and angle of refraction. So then you are able to find out the angle of incidence that strikes the face AC. And further you have to, when you got angle of incidence, so then it is very simple. You can easily find out n is equals to sine r over sine r to find out the value of refraction angle. So you just measure the angle of incidence from here, and then you can find out the angle of refraction with the help of formula because refractive index is given. And in the final B part, without further measurement or calculation, sketch on figure 7.1 the approximate path of the ray after passing through the face AB. So basically now we have to show the direction of the light ray that starts to pass away from the prism. So now light ray is moving again from dense to rare medium. So it will, this is the normal line. Now it will bend away from the normal. So it bends away from the normal. So this is the direction. Part C, figure 7.2 shows a ray of light traveling within an optical fiber. So when it is moving within the optical fiber, so this is the light ray coming from right hand side, striking the point X. So complete the path of the ray light to the left hand of the fiber and name the process taking place at position X. So which process is taking place at point X? And we know that how to, yes, total internal reflection, and we have to draw completely total internal reflection from the optical fiber. So questions are also very simple from light section. It is not very difficult when you continuously practice like by yourself also for 1 day or 2 day, like 1 hour, 2 hour daily. So it will also be easy for you. You can see mostly questions are like the same. Diagram questions are also not difficult. Okay, this is a different question from the others. It shows particles of a material in which sound wave is traveling. Okay, this time we have sound waves. On figure 6.1, mark the center of a compression with letter C. So this is very easy because we know compression is when particles are close to each other. So you can just identify there is a complete pattern. You can see this is pattern. So you are getting exact pattern, right? And this is the center of compression, C. You can also mention either C over here or C over here because this is the center. Because this is the point where the particles or the dots are very close to each other. So this is the center of compression. And in the same way, you have to identify the center of rarefaction with R. It is also simple. Now again, you have to find out the pattern. This is the pattern for rarefaction. This is the pattern for rarefaction, right? So this is center. This is center. And in part 3, one wavelength with a double-ended arrow. So now you have to show one wavelength with one double-ended arrow. So for wavelength, the distance between two consecutive crusts or the consecutive trough is called wavelength. So in this, you have to show like the distance between two consecutive compression or two consecutive rarefaction. So that will show you the wavelength of one wave, right? So like this will be your wavelength. This is the distance between two consecutive compression, or you can mention from this distance between two consecutive rarefaction. So that will show you the wavelength. Okay. Now circle one value from the list, which is the speed of sound in water. So this part is also simple. We already discussed this question already related to the same value. So it is also simple. It will be equals to around 1500, and the wavelength of the sound wave in the water is 12 centimeter. So this time wavelength is given. You have to find out the frequency, and wavelength is in centimeter divided by 100.12 meters. Speed is already marked from part B. Divided by 0.12. Or you can also round it off to state and explain whether the sound in C is ultrasound. So you have to mention the statement and also the explanation. So this frequency is ultrasound frequency or not? Okay, wait one more. 12,500. It is 13,000 because initially we got 12,500. So we know that this frequency is less than 20,000. So it is not ultrasound wave because ultrasound is greater than 20,000. It is less than 20,000 hertz. This is also very simple. It is related to electromagnetic waves, and it shows the position of X-ray in the electromagnetic spectrum arranged according to the increasing wavelength. So this is increasing wavelength. We have visible light over here, and some points are missing like J, K, L. So three components of the spectrum are unnamed but labeled J, K, L. State the name of the three components. So we know on the side of microwaves, it is equals to infrared. This is ultraviolet. This is radio. Ultraviolet, infrared, radio waves. And state which of these three components has the lowest frequency. So from these three, we have to choose the lowest frequency. So you can see lowest frequency is for radio because radio have greatest wavelength. And again, they are asking the same part, calculate the frequency. We know that all electromagnetic waves travels with the same speed, that is speed of light. And a wavelength is given. So now it is also simple to find out the wavelength of the wave in the vacuum.